Okay, we're back here with the test flight of that ship we built in the last video. So I'm gonna start off testing out the VTOL first, just to make sure we've got all that all nicely balanced. So I'll just open up the bay, get the engines kicked up, turn the RCS on for the stabilising verners, and now we just have to wait a little bit for the engines to spool up. Because, you know, the VTOL jets, same as any jets, they take a bit of time to get going. You can see the light reflecting on the ground underneath, and they're getting some glow up. And, yep, I think we're just about to lift off. So there we go. Almost. Come on. Come on. There we go. Yep, cool. Okay, so perfectly flat and stable. All lovely under control. Everything's balanced as it should be. So with VTOLs, it is possible to do fancy things down just skimming ground level. But you do want to be pretty familiar with your aircraft before you try that sort of thing. You need, because of the delay in the jets and such, you need to react to things before they happen. So you need a pretty good sense of timing of how long it's going to take me to fall to this altitude, how long it's going to take the engines to spin back up again to reverse that fall. So when you're first taking a VTOL up, it's usually a pretty good idea to get a bit of altitude before you play around to see how it behaves. But yeah, we are going up quite quick, so what I'm doing here is I've cut throttle a bit, and I'm also tilting forwards, so that'll get us moving forwards, but it also directs some of the thrust away from lifting us. So that's another thing that will slow our climb rate. Because, yeah, I want to get some clear air under me, so I've got a bit of safety margin while we're testing. But, yeah, VTOLs are for use close to the ground, so I think I'll take us down, buzz over the top of KSC before we do anything else. So, yeah, carefully adjusting the throttle here, down to about a third, and, okay, that tilt there, that's how you change direction when you're VTOLing. You don't do it by spinning your nose around, because that just keeps you going sideways while your nose stays in the same direction. Well, yeah, you go in the same direction while your nose goes to sideways. To actually change direction, you need to tilt, and to accelerate, your nose down, to brake, your nose up. So we're still accelerating slightly forwards here. Okay, and we're dropping, even though I've got the throttle up on full, because, you know, it's taking the engine's time to get back up again. But that's okay, because I did want to bring us down a bit lower over the space center. And I need the throttle up full long before, you know, leveling out, because if I wait until we're at the altitude we want over the space center and then kick the throttle up, I'm going to crash into something before the engines spool up as much as I need them to. But here we go, we're back to level flight, so we'll wind the throttle right back down again. And again, there's a spool up time in winding down as well as winding up, so it takes a fair, even though I'm down at fairly low throttle, we're still hovering along flat, but as time goes on, I'm going to have to increase the throttle or do something else, because, you know, as the engines spool down, we're starting to drop, so we're now going down at about, you know, 8 meters a second or so. That's okay, we do want to come in and have a look at things anyway. Those helipads on the... It's possible to land one of these on the roof of those helipads on the vehicle assembly building. They are a very tricky target, though. You know, it takes a bit of practice before you can... Like, just landing a VTOL successfully anywhere takes a bit of practice. Landing a VTOL successfully on a small target is quite a precision job. But here, you can see using the verners as a little bit of boost. So those give me much finer and faster responding control for changing my vertical speed. And using them in combination with the jets is good too, because you may set your jets to a level of throttle that would hold you nice and level, but while the jets are spooling up, you use the verners to fill in the gap, and then once the jets have got up to the point where they can do it themselves, then maybe let go of the verners. They're also good for softening landings, all that sort of thing. But let's try and kick up the main engines. Have a look at how you do the conversion from one to the other. So you see, I haven't shut off the VTOL engines immediately, because if I do, we'll just fall out of the sky, because we're not going fast enough to fly, especially on a ship like this, which doesn't have very big wings. So, you know, therefore needs a fair bit of speed to maintain level flight. But just keep the jets on for a bit. And you can see we're picking up vertical speed pretty quickly here, horizontal speed, sorry. So once we've got enough, just a little little bit more time, a little bit more time. Yeah, so about the same sort of speed you would pull the nose up when you were taking off on the runway. Then you shut off the VTOL engines, close the bay. Okay, you see my prograde vector is dropping sharply now that I've no longer got the lift from the VTOL engines. But I've now got enough airspeed that I can reverse that just by pulling the nose up as usual. But here's where I'm noticing one of the first problems with this design. All that extending of the fuselage I did to give it that long neck, you know, the stretchy out nose towards the cockpit, it's getting a bit wobbly. Okay, you can see there's a little demonstration. That fuselage is actually flexing quite alarmingly. And that's not just a structural problem, it's also causing all sorts of aerodynamic issues because the relationship between the canards and the wings is not staying constant. Those canards are shifting up and down a metre or so as the fuselage is flexing, and it's making the plane, well, it's already also needs a bit of tuning on the control surface strengths, but which is making it a bit surging already. But that flex on the front is making it surge even more, and it's making it a bit difficult to control here. Like it's not in danger of spinning out of control or anything, but just it's overreacting to control inputs. So give it a bit of rudder, try and get us back on the 90 bearing, try and pull the nose up a bit, and you see the atmospheric pressure is getting high because we're going too fast, too low, because I haven't climbed much. So, and we're nearly doing supersonic, only a couple hundred meters off the water. So I want to pull up the nose here to get us to climb, but whoops, okay, we obviously have some design problems. Lodbald and Bob are possibly not having a good day today. So let's use the magic of Kerbal to shift forward again though. Take off conventionally this time, and you see it takes off just fine. And I've added a fair bit of reinforcing, so you can see there from around the front landing gear back to the lateral pods there's a pair of struts. There's also a few small pairs of struts stuck in, less obviously, but as you saw there, fuselage flexing was not the only problem. Those wings are just too weak. So what I'm doing here is bringing up the strength of the wings a bit. Now, default strength wings 1.0 is very strong, very heavy, and they're massively overkill for most purposes. With a lot of craft, you can wind them down to as low as 0.35, 0.4, and they'll still work perfectly fine, especially if you fly sensibly. But the strength required for wings is affected by the design of the aircraft. An aircraft that has really big wings has what we call a low wing loading. And a low wing loading craft can get away with weaker wings than one like this one, which is high wing loading. Okay, wing loading basically means take the area of wing and divide it by, well, take the weight of the aircraft and divide it by the area of wing. So the smaller wing, the higher wing loading. So sometimes it's a bit of balance. You'll think smaller wings, less weight, but on the other hand, smaller wings are going to need to be stronger. So yeah, that weight difference isn't quite as big as you think. But smaller wings are not just about less weight, they're also about less drag. So we've heavied it up. I had to rearrange the VTOL jets a little bit to keep everything in balance. Just do a little test there to make sure that we can still lift off with the new heavier wings, and we can just fine. So let's skip it up to altitude, see how it behaves with this airframe. Now you may remember from the previous vid, it's not quite perfect. There are some problems with it. In particular, there was some yaw stability problems and some pitch stability problems. So we've got up to a good speed here, and we're getting up towards the higher altitudes. So let's have a look how it behaves when I try and pull the nose up to get us climbing, because we're still dropping a little bit. And bang. There we go. Remember the pitch up problem? That's what it does. It makes it hard to control how much you pitch up, and if you pitch up too much, especially at not high enough altitude, bad things start to happen. Lodbold and Bob are not having a good day. Alright. Nice explosion, so very pretty. It lags the computer down, but I don't actually mind that much because it gives you little snapshots of the fireworks. But yeah, so assorted things broke. That was not good. So let's try that again. We'll just pilot a little more carefully this time. Just don't pull the nose up sharply like that. Ease my way up to higher altitude. And I've managed to do that. We're up in thinner air now, but you remember we didn't just have pitch stability problems, there was also some yaw issues, and you can see that here. The nose keeps trying to wander from one side to the other, and I'm having to fight to try and hold it straight. And I've got, even with the Verners on, you know, to give me a little bit of extra boost, because up in this thin air, the rudders have very little grip, but it's wobbling back and forth. I'm also starting to get some roll as it's going back and forth. Yeah, this is the sort of thing that a good pilot could possibly fight through to get it to orbit, but really, it's not good. This is not the sort of standard plane I would release for somebody else to use. It's getting rather ugly now. So, fight, come on Bob, hold it, no, nah, that's gone. Spinny. Okay, because we're up higher now, the plane's not immediately exploding because there's a lot less air hitting it, and this is actually savable, and if I went on with this, you could see I can pull this back to prograde and carefully keep going to orbit, but that's not how you want to go to space. So, we'll be back next video with another one where I show how to fix all these problems. So, cheers.